Okay, continuing with part 4 of our study guide. In the diagram below, we see that TB is parallel to BC. So remember, these are the marks. They make little triangles on those figures when they're parallel. And it says that AT is 7, so I'm labeling my diagram. TB is 9. AV is 12. And they want to know the length of BC. So here again, we could use those corollaries, but the method that I'm going to show you is one that always works. So I'm going to call this piece X, okay? And 7 is to 16 because this whole length is 16, and this little triangle is similar to the big one. So 7 compares to 16. Do you see where I got 16? Okay, so this is the challenging part. And this side is going to be 12 plus x. So if we take a look at the proportion, 7 is to 16 as 12, this piece, is to the whole side. And the whole side is 12 plus x. So now we have a proportion. And the problem with this proportion is you have to use the distributive property. So 7 times 12 plus x times 12 plus x equals 16 times 12. And so as we multiply this, 7 times 12 is 192. So 192 plus 7x equals, and 16 times 12, I'm sorry, I got that backwards. I wrote it down the other way. 7 times 12 is 84. 84 plus 7x equals the 192. That's where I was getting 192 from. So solving this, subtract 84 from both sides, and you get 7x is equal to 108. And so x is equal to, how many times does 7 go into 108? It's a decimal. So don't be alarmed when you get decimals. It's about 15.43. So they want to know the length of BC, and that's what we said x was. So that is the answer. If they wanted to know the length of AC, you'd have to add that back to 12. Okay? All right, number 27. Find the coordinates of point K. So notice that they've given coordinates here. Well, the very first thing that I'm going to do is to figure out the lengths. So these are both on 2, so it's up 2. So what's the distance from 2 to 8? I could use the distance formula, but in this case, it's almost easier to count. So this length is 6, because 8 minus 2 is 6, and they're both on the same y coordinate. Okay? This one has a length of 12, because 12 minus 0 is 12. And this one goes from 0 to 16, so this length is 16. Now I could use the distance formula and find the distance from here to here, but it's much easier to use these two that I can just count. So if this was on a coordinate plane, I could just count the spaces. So this triangle is similar. So 6 is to 12 as x is to 16. So using cross products, 12x and 6 times 16 is 96. So 12 goes into 96 8 times. Well, some of you are going to be tempted to put 8 in these blanks, but that's not what you need to do. Because this is 8 and this is on 2, 2, this is going to go straight up. So the first coordinate is 2, and the second coordinate is going to be 2 plus 8. What's 2 plus 8? 10. So this is going to be 210 for this. Because this second one, I have to add 8 to find out where K sits. So K is 210. So lots of problem solving in that one. 8. This one is about the Washington Monument. Ms. Hope decided that she wanted to know the height of the Washington Monument. So this is a strategy that works with finding heights of things you can't measure. Okay, we're going to use similar triangles. So she placed a mirror a certain distance, 1,160 feet, from the figure. Then she backed up. She knows her height. She's pretty short, only 5 foot. And she sees the tip. So these two triangles are similar. This angle is the same as this angle is the same as this angle, and of course these are 90-degree angles. So we use similar triangles to figure this out. So we can write a proportion. So this is what we're trying to figure out. So x compares to 5, and this time I did big to little. I hope that doesn't confuse you, just because I like the x to be, if you want 5 over x, the proportion will still work as long as you do the next piece the same way. And so the next piece is going to be 1,160 over 11. So there's our proportion, because these triangles are similar. So 11x, using cross products, equals 5 times 1,160. And that is 5,800. Please use your calculator, make sure I didn't make a mistake. And 5,800 divided by 11 is 527.27, and the 27 repeats. So that is the height of the Washington Monument. We don't need to add any other work to that. 527.27 feet. So problem solving pieces. Okay, taking a look at 29. You need two proportions. I'm going to find x first. And the proportion is going to be 300 to 420. Because these are parallel, this is going to be, not right now. Because these are parallel, these are going to be similar triangles. So this angle is equal to itself. This angle is equal to this angle. And this angle is equal to this angle. Okay? So because these are parallel, we know that. Now, 300 is to 420. And if you were using the split corollary theorem, you could simply do 100 is to x. Okay? And then solve that proportion. You should get the same value for x. I'm going to show you the other method that always works, even if these triangles, even if these pieces, this piece is not in proportion with this piece. So this is 400. 300 and 100 is 400. So that side is 400. And this side is 420 plus x. So that's how I would write that. So this is more like the question that we did on the other side of the page. So 420 plus x. So using my cross products here, 420 times 400. Somebody pick up your calculator. What's 420 times 400? Actually, I could make my job a lot easier by reducing 300 to 42, couldn't I? So let's do that. You could use that, but your numbers will be a lot bigger. The zeros cancel out. That was supposed to be on the zeros. And 30 over 42 is 5/7. So isn't 300 to 420 the same as 5/7? And those numbers are a lot easier to deal with. So now my proportion is still true. And I'm going to do 5 times 420 plus x equals 400 times 7, which is 2,800. So 5 times 420, sorry? 5 times 420 plus x. I did cross products. This times this.
An emergency.
So what is 5 times 420? 5 times 420. 2,100 plus 5x equals 2,800. So 5x, if I subtract 2,100 from both sides, 5x is, and I know I'm going to have to erase that, 5x is 700 or 800? 700?
Yeah, 700, 700.
So what is x? How many times does 5 go into 700? Is it 140? So x is 140. So this side is now 420 plus 140. So that's 650, isn't it? So I'm going to use this same proportion. 5 is to 7. Because that's 300 is to 420 reduced. Because that makes things simpler. And this was 650. 420 and 140 is 650. 650 over 650 plus y. Okay, so now I'm doing the same exact thing. 5 times 650 plus y equals 7 times 650. So picking up your calculator, this is 4,550. And 5 times 560 is 2,800 plus 5y. So 5y is 1,750. Subtract 2,800 from both sides. Now divide both sides by 5. And you get y is equal to 350. So, now we have the one where you have to draw a picture. I'm going to push us on through it because we have 6 minutes left.
No, we don't. It's 10.
What?
It's 10.
That's 5 times 650 plus y. Okay, so we have a tree. Here's our tree.
That's like a Christmas pine.
Yeah, it's 15 feet tall. And it casts a 12-foot shadow. So here's my 12-foot shadow. How far away from the tree must a 4-foot tall girl stand if she wants her shadow to end at the same point? So here's the young lady. She's got on a skirt. And she wants her shadow to end right here. Right? So do you see that these are parallel and that these are going to be similar triangles? So she's 4 foot tall. So 4 is to 15 as x is to 12. So 15x equals, what's 4 times 12? 48. So now divide by 15 and you get 3.2. Well, that's not the answer to the question because the question said how far away from the tree does she need to stand? So remember, this shadow is 12 feet So she needs to stand 12 minus 3.2 away from the tree. So what is 12 minus 3.2? Is it 8.8? Did I do that right? 8.8 feet.
Can I answer it? I'm gonna still
No. Questions?
Really?